In this lesson, we're going to demonstrate how to limit flooding and increase network security with VLAN pruning. For this lab, we have a scenario of managing 3 different networks on 3 different floors inside the building. The 192.168.1.0/24 network resides on the first floor. The 192.168.2.0/24 resides on the second floor. And the 192.168.3.0/24 network resides on the third floor. And as we can see, each of these networks maps to a specific VLAN, whose VLAN number and name can be seen on the right-hand side of the screen. I will start off by creating the 3 floor switches. So I'll navigate to Network Devices, Switches, and I will create 3 switches, which I'm going to call SW1 for switch 1, SW2 for switch 2, and SW3 for switch 3. Next, I'm going to connect each switch to its respective PC. And then I am going to add a layer 3 switch or multi-layer switch to the workspace, which will act as our core switch. Then I am going to connect the 3 floor switches to the core switch. Like so. And the next thing I'm going to do is to configure each floor switch in turn. Starting with switch 1. So I'll go to switch 1, navigate to CLI, run enable, conft VLAN. Let's see what VLAN we need to configure in it, which is 30, name IT. And then we need to go into the interface connected to the PC, which I believe is 0/1, and run switchport mode access, switchport access VLAN 30. Finally, we need to configure the trunk port, which is 0/1. Save our changes and close the window. Similarly, into switch 2, enable conft VLAN 20, name HR, interface fast Ethernet 0/1, switch port mode access, and then switch port access VLAN 20. Finally, we need to configure the trunk port, which is 0/1, and save our changes. Close the window, and into the final switch, enable conft VLAN 10, name finance, into the interface facing the PC. We'll make it an access port and we'll make it a member of VLAN 10. Should be gigabit Ethernet 0/1 connected to the core switch. Switch port mode trunk. Save the changes and close the window. Fast forward the time. Having configured our floor switches, we now need to configure the core switch, the last component of our infrastructure. So I'll go to the core switch, into the CLI, run no, enable conft. I shall begin by configuring the VLANs, exactly the same as before. name finance, HR for VLAN 20, and IT for VLAN 30. Next up, I need to configure the switch virtual interfaces or SVIs. So I'll run interface VLAN 10, the address. The network of VLAN 10 is 192.168.1.0/24, so I'll give the IPv4 address of 192.168.1.1. 255.255.255.0 is going to be its subnet mask. No shutdown. Then I need to configure the VLAN 20 virtual interface. VLAN 20 has the 192.168.2.0/24 network. So I'll make it 192.168.2.1, 255.255.255.0. No shutdown. And finally, VLAN 30, 192.168.3.1, 255.255.255.0. No shutdown. And we need to enable IP routing so that this switch can act as a layer 3 switch or multi-layer switch. Save our changes, close the window, fast forward the time, and I will verify inter-VLAN connectivity between the various flows, which is why I will launch a command prompt on the PC of the first floor, which has the 192.168.1.10 IPv4 address, and I will ping 192.168.2.10, which is the IP address of the host on the second floor. We can see that it's thinking about it, and in the end, the first request got timed out, but the subsequent 3 were successful. Similarly, if I open up the command prompt on the PC of the second floor and I ping 192.168.3.10, which is the PC of the third floor, we can observe exactly the same behavior. The first request got timed out, but the other 3 were successful. So this verifies that we have configured inter-VLAN connectivity between our various switches on all 3 floors. What I would like to do for you guys now is to demonstrate the current behavior of our internetwork without any VLAN pruning taking place. I will go to the PC of the first floor, back to its command prompt, and if I run up A, we can see that it has already stored some information. So to start from a clean slate, I will run up-D and verify that the app cache of this PC is empty. Next, I will run the same ping, but just before I do it, I will go into simulation mode in order to capture the traffic. I will initiate the ping. I will slow down the speed of the packets. And look what's happening now. We can clearly see that the broadcast traffic generated by the PC is flooded by the core switch through every trunk across all floors. This unnecessary traffic flooding wastes uplink bandwidth and increases congestion, especially in large networks. What's more, this phenomenon has a negative impact on network performance, as more traffic means switches must process more frames they don't actually need. Not to mention, there is also a security risk in that an attacker who gains access to a trunk could see more VLANs than necessary. To address this issue, therefore, we will proceed to configuring VLAN pruning. I will go into the core switch and enter the trunk to the switch of the third floor, and I will run switchport trunk allowed VLAN 30. As you can tell, this command tells the core switch to only carry data about VLAN 30 on this particular link. I will also tell the core switch to carry VLAN 20 only on the trunk leading to the second floor and VLAN 10 on the trunk leading to the first floor. The command is the same in all cases, with the only difference being the specified VLANs. I will save my changes and close the window. I will fast forward the time and let's see if we will observe a difference this time around. I will go back to the PC of the first floor and clear its app cache to generate some fresh broadcast traffic. I will go into the simulation mode and run the same ping command as before. If I step through the traffic, we can see that the core switch receives a broadcast frame yet again, but this time it doesn't flood it through all trunks as it did before, thanks to the VLAN pruning configuration we put in place earlier. If you wish to see what VLANs are allowed on each trunk, you simply need to run show interfaces trunk, and you will be able to see which particular VLANs are carried over each link.